about the OLED concept, and we have taken the output of the OLED. So now we are going to discuss about the generation of real-time clock using the ESP32. So we know in general, real-time clock is nothing but the time, hour, minutes, day, which day, and date. So we are going to generate a real-time clock which are going to display a hour, time, minutes, seconds, date also with month and year. So here we can have a ESP32 IoT trainer kit, and here we are not going to interface anything. So this is going to run with the help of our standard interface. So we know we have standard interface like RS432, IC, SPI. So various standard interfaces we are using. In here we are going to use the IC, I2C and SPA, two standard interfaces we are going to use. Okay. Now you can see we have the code for the real-time clock. Now I have defined the address, and I have called out the decimal to binary conversion, and now we are going to implement the decimal to binary conversion, mentioning it as a 16-bit. We are going to begin our serial conversation, and we are using the bandwidth of 9600, and we are going to set the time limit, and we are introducing the delay, because each and every second should have a delay, right? So we are introducing the delay of 1000, and next we are going to write the decimal to binary code for each second, minute, hour, etc. So you can see we are writing the decimal to binary conversion for the second, minute, hour, and day of a week, day of a month and year. So we are going to execute seconds, minutes, hours, day, month and year. So we have already written this. Now we are going to enter into the write statement. So first of all, before getting into the write statement, we should also have the statement of read. So only it can have a print option. So we are going for the byte second byte. We are defining it as a byte, and we have defined all the variables. Now we are going for the starting of our conversion. So here you can see we are requesting from DS. This is an address which we are introduced for the conversion process. Now we have started our addressing format. For second, we are converting the wire dot read. So wire, we have given the term as variable as wire. So now we are going to read the second, minute, hour, day, month, year and etc. So these variables, now we are in a reading format. Once we have read, we have to display, right? So next we are going for the display of these variables. Once we have going for display, we have to use the option as serial.print. So we are going to print in a serial format, and we have to give the print option for each and every variable. So individually I am giving the each and every variables with a print statement. And for each case, like if it is Sunday, it will be calculating the minute, hour, seconds for overall Sunday. Once the Sunday is over, it will go for the second case. So for a Sunday, it starts from 00 second. From 00 second comes for 01 minute, and after 01 hour, and after that it goes for 24 hours. Once the 24 hours is completed, it goes for Monday. So starting will be our Sunday. So now the loop continues, and it starts from the 0 to Saturday 24 hours. Now I am going to dump this code to my ESP32 kit. Once the ESP32 kit is done, it reads from our standard interface. Once it is read, we will be seeing it in a serial monitor. You can see here it's a compiling, and now no port provider. So why this option appears here is we have not connected any port, right? You can see we have the option on and off. So here we have to give our serial input. Now we can dump. Once the dumping option is over, we can go for our serial monitor, which you can see here. This is a serial monitor. Once if it is done, the serial monitor will be able to give you a code automatically. Since it have an connectivity error, it's not uploaded yet. Once the code has been uploaded, you can see the each and every second simulations.